In 1938, a scientist put an injured minnow into a tank of healthy minnows and watched the whole shoal panic. No predator, no visual threat, just a wounded fish. That single observation launched over 80 years of research. Welcome back to the channel. Today, we're talking about Schreckstoff. The story begins in 1938 with a Nobel Prize-winning Austrian scientist called Karl von Frisch, probably best known for his work on honeybee communication, the waggle dance. But von Frisch was endlessly curious about how animals signal to one another, and he turned his attention to fish. He was studying European minnows when he noticed something remarkable. When an injured minnow was introduced to a tank, the other minnows reacted as though a predator was present. They scattered, they froze, they dropped to the bottom, but there was no predator, just a wounded fish. When von Frisch removed the olfactory nerves of the surrounding fish, the response disappeared entirely. So it wasn't visual, and it wasn't vibration through the water. It was chemical, carried through the water and detected by smell. He named this substance Schreckstoff, German for fright substance, or as some translations put it, scary stuff. The paper was published in 1941, and it kicked off over 80 years of scientific investigation that's still ongoing today. So, what exactly is it? Schreckstoff is released from specialized cells in the outer layer of a fish's skin. Cells known as club cells, also sometimes called alarm substance cells. They sit just beneath the surface of the epidermis, and crucially, their contents can't be released voluntarily. The only way they rupture is through physical damage, specifically when a predator's teeth, beak, or claws pierce the skin. That mechanical damage is key. It means Schreckstoff is only released at the moment of genuine attack, making it an extremely reliable signal. No false alarms, no crying wolves. For decades, the exact chemistry of Schreckstoff remained frustratingly unclear. One proposed active ingredient was a compound called hypoxanthine 3N oxide, a nitrogen oxide compound, and research by Brown and colleagues in 2000 confirmed that nitrogen oxide functional groups were key triggers of anti-predator behavior in nearby fish. Another component identified was chondroitin sulfate, a glycosamine glycan, essentially a long-chain, sugar-like molecule found in fish mucus and connective tissue. When researchers broke down the chondroitin in Schreckstoff using enzymes or neutralized it with antibodies, the alarm system response was suppressed. Expose fish to chondroitin alone, and you could still trigger darting, slow swimming, and bottom-hugging behavior. In 2024, researchers at the Riken Center in Japan, led by Yoshihara, published a landmark paper in the journal Current Biology that finally identified the specific compounds involved, at least in one species. The research was conducted on zebrafish. Rather than dropping chemicals into a tank and watching behavior, which had proven unreliable in previous studies, Yoshihara's team screened directly for brain activity, and what they found was that Schreckstoff isn't one signal, it's two. The first compound, Ostariophysan, was found across multiple Ostariophysan species. This is the shared danger signal. The second, dinyl sulfate, is unique to zebrafish, the species-specific signal that says one of us is hurt. Both had to be present simultaneously to trigger the full alarm response. Neither alone was enough. You can watch the video of the zebrafish experiment using the link in the description. The classic view is that Schreckstoff is a feature of the superorder, and that covers the vast majority of UK coarsefish: roach, rudd, dace, chub, bream, tench, carp, barbel, and so on. All of them have alarm substance cells in their skin. But research over recent decades has revealed the picture is more complex. Alarm responses to conspecific skin extracts have been observed in perch, darters, gobies, sticklebacks and so on, none of which are Ostariophyzans. The 2016 study in Scientific Reports even described a clear alarm response in Medaka, a species believed not to have classic club cells. The cortisol levels of Medaka spiked measurably within minutes of exposure to injured conspecific skin. This suggests the system is more widespread than originally thought, and that in some species, different cellular mechanisms may produce functionally similar chemical signals. When a prey fish detects Schreckstoff in the water, the behavioural responses are immediate and varied. Researchers documented rapid darting movements, tight schooling or shoaling, freezing or hugging the bottom, reduced foraging activity, and movement to cover or structure. And here's where it gets even more interesting and more relevant to us. If Schreckstoff is released every time a fish is attacked, does that mean predators can smell it and use it to find more prey? The theory is compelling. Follow the chemical trail of an injured fish to find a shoal in panic. The evidence is mixed. Some studies support the predator attraction hypotheses. Others, like Molly Kashner's work at the University of Southern Mississippi, found that spotted bass showed no interest in foraging behaviour when exposed to Schreckstoff containing skin extracts from prey species. In 1996, Shivers and colleagues published a paper in American Naturalist arguing that attracting additional predators actually benefits the original alarm signal sender by disrupting the attack. Essentially, calling in a rival predator to steal the prey causes the first predator to abandon and flee. The honest scientific position is, in some species and contexts, predators probably do exploit Schreckstoff, in others they don't, but the research is ongoing. But here's the question that stumps evolutionary biologists for decades. Why would a fish evolve a system that only works when it's already being eaten? An injured fish can't benefit from warning its shoalmates, it's already being killed. Several hypotheses were proposed. Kin selection, the idea that warning related family members improves inclusive fitness, was tested in fathead minnows and found to have little support. The evidence didn't show preferential production of alarm cells when fish were in groups of related kin. Here's the part that really blew my mind anyway. These alarm cells, they probably didn't evolve as an alarm system at all. The leading hypotheses, published by Brown and Shivers in the Proceedings of the Royal Society B in 2006, suggest they originally developed as an immune defense to fight off fungal infections, water mold, parasites, and UV damage. That was their job, protecting the fish from the outside world. But here's the twist. When a predator attacks and ruptures those cells, all the chemical content spills into the water, and over time, nearby fish evolved the ability to detect it and run. The alarm system was essentially a happy accident, a biological side effect that became so useful, natural selection kept it. So Schreckstoff wasn't designed to warn other fish, it just turned out that way. Now it's worth being clear, this is scientific theory and not established fact. It hasn't been proven, but it's the most compelling explanation we currently have, and supporting evidence is strong. But the full evolutionary origin of these cells is still an open question. What we can say is that every fish in your waterway has been running the same accidental alarm system for millions of years, whether it was designed for it or not. So what does all this mean? Let's start with something I think every predator angler, well, catfish angler will recognise. You've got a live bait out locked into position on a dumbbell rig. The float is sitting perfectly still. Then suddenly it goes absolutely crazy. Erratic, frantic movement for 5 or 10 seconds. Then it settles again. No take, no predator showing. What was that? It could well have been Schreckstoff. If another fish was attacked somewhere in the water, even out of sight, the chemical signal drifts on the current. Your live bait detects it, panics, and thrashes against the rig until the signal disperses. The predator never came near your bait, but your bait knew something was happening. That to me is Schreckstoff making itself known on the bank. And once you know what it is, you start seeing those moments differently. Now, is Schreckstoff something Pike or even Xander are actively hunting by? Probably not in any significant way. Pike are primarily visual and lateral line hunters. The research on whether predators hone in on Schreckstoff is genuinely mixed, and there's no strong evidence it draws them in reliably. Where Schreckstoff really matters to us is in understanding why prey fish behave the way they do. Why a shoal of roach was sitting confidently in open water 20 minutes ago has completely vanished. Why a live bait on a drifter rig suddenly changes direction and pace for no reason you can see. Something in the water told them to, you just couldn't detect it. These fish are reading their environment on a chemical level that we're only beginning to understand. And that to me is what makes predator fishing so endlessly fascinating. Schreckstoff, fright substance, scary stuff, whatever you want to call it, it's been woven into the fabric of freshwater life for millions of years. A hidden chemical conversation happening beneath every surface we cast into. Karl von Frisch first heard that conversation back in 1938, and over 80 years later, we're finally starting to understand what it's saying. If you found this as fascinating as I did, hit subscribe, because we've got plenty more deep dives into science and ecology of our freshwater predators coming. Drop a comment below. Have you ever witnessed what looks like a Schreckstoff response on the bank? A shoal scattering for no obvious reason? I'd love to hear about it. And until next time, stay hooked. I'm Stu, a British military veteran, and predator angling runs deep in my veins. It's about wild waters, the chase, and a way of life. If you enjoyed this adventure, hit subscribe. And if you want to go even further, join my channel memberships for raw, unfiltered predator sessions and exclusive films you won't see anywhere else. This is Hooked on Predator Fishing, and until next time, stay hooked.